Welcome back to a universal modeling framework for sequential decision problems, bridging machine learning and stochastic optimization, part 5. This is where I'm going to talk to you about teaching sequential decision analytics. Now, let's imagine that we're in this village and we've got these cute shops, and each of the shops are selling something specialized. Maybe it's baked goods, and I can go into the bakery shop and it's all full of wonderful smelling baked goods. Or I can go into the butcher shop and there's all these select meats I can choose from. Then you have the grocery store, the dairy store, and it's all very specialized. This is pretty much what we're doing in the world when we make decisions under uncertainty. Each one of these books is like its own little shop. It speaks its own language, it has its own tools, and it's highly compartmentalized. And the problem is, when you go to real world problems, you really need to draw from the collected wisdom of these books. So I would like to create a supermarket where you can go into one place and find anything that you need. And so this would be like a supermarket for algorithms. I'm going to claim that I've done this in my first book. I call this my big book. It's 1,100 pages. It's a graduate level textbook. It's the first book written completely around the universal framework covering all 4 classes of policies. It describes the tools for modeling and solving any sequential decision problem. At Princeton, last time I taught this course, I had 50 graduate students from 10 different departments, including every engineering department. I had students from politics, economics, I think physics. So it's written at a mathematical level that you would need if you were going to develop computer software. Now, a second book, I wrote this for the undergraduates. Now, this is also a companion book to the big book, but you can use it by itself. This book uses a teach by example style. Every chapter other than chapters 1 and 2 is a different application. It's all written in the same style. I have a narrative. I have the 5 elements of the universal modeling framework. I talk about how to model uncertainty. Then I talk about policies. By the time you finish chapter 6, you have seen examples of all 6 classes of policies, along with different ways of modeling state variables. I pull that together in chapter 7 and compare them. Then you have other applications, but I also encourage people to say at some point, start working with your own applications because it's very easy to apply. I'm also working on a new monograph series, and volume 1, I have a draft of that. I hope to have it out on Kindle in the coming months. This focus on framing the problem, addressing 3 questions. What are the performance metrics? What types of decisions are being made? And what are the sources of uncertainty? This book, it's about 160 pages and no math. I'm emphasizing the need to start in English. Volume 2, nearing completion as I'm recording this. This is the Universal Modeling Framework, all 5 elements. It does use the mathematical notation of the modeling framework. However, it's done with a tremendous number of examples and illustrations. So in other words, it's not just the notation, it's the notation illustrated. This is absolutely my best modeling work that I've done. By the spring, I hope to have finished volume 3. Volume 2 will not say anything about how to make a decision. That's for volume 3 for designing policies. And instead of just rotating through the 4 classes of policies like I do in the big book, I'm going to introduce these in the order in which I think they're most useful and most widely used. So I'm going to start with the policies that everybody does, and I'm going to end with the least useful policies. So I'd like to thank everybody for listening, even if you haven't done all 5 parts. I think this is a fundamental rethinking of how we approach optimization problems, especially the more complex math programming problems.